because those joints in your real life, in your theoretical, there is a pin joint, rigid joint, sometimes semi-rigid, but connecting those two bamboos with the rope, are you considering as a rigid joint or pin joint? So project, again another view for the same project. I also work on this magnificent iconic building. Two, those two legs are two shear walls, two cores. Those are cylindrical cores, which are the initially those two cores were at the same length and same space and angle. But due to dynamic behavior, we are finding some torsion. Then we slightly shifted their location. Now they are like not parallel, but inclined. And because of that, first step forward comes to picture. And these two cores, again, there is some secondary structure to receive the facade. And again, it was done in ETABS, the base building, which is like inclined roofs and everything in ETABS, and the top also in ETABS, and so in. So these two like major complicated buildings or towers, we do in two separate softwares. Sometimes ETAB, sometimes GSA, sometimes robot, to verify the results. Okay, so we use 2-3 softwares for this building. Again, it's a mass residential development, high-rise towers. Now we'll go to the actual ETAB thing. Is everything clear from last session? Is there any major concern? Apologies if I was a bit slow because I want to touch many basic concepts. You must have experienced consultants also there. You may think that it's not the right way or ask questions, but it's always good to touch upon basics. So I touched it. Is I'm asking any question? You can unmute and say like, is everything clear from last session or not? Hello, am I audible?
Hi. Yes, sir.
Yeah.
Okay. We'll start upon ETABS. So ETAB was like it's a as the name says, it's an extended three-dimensional analysis of the building structure. So it's a part of a product of a CSI product, like a computer structural analysis is a big firm. Professor Habibullah is the originator of this computer-aided structural design, and they have a range of softwares. Like they started with SAP, they started with actually Syscall, then Perform 3D, then SAP, then ETABS, and now SAFE. So they have big range of computer analysis structures. So SAP is their general program. You can create and design, analyze, breach, silo, water tank, anything. Here in ETABS, it's only specific a module for your building structures. It's not a general software. It has the basic limitation of that. You can't create a big shell structure water tank. You can create, but it will not give that much accuracy results for you. So this is basic understanding you have to understand. ETAB again work with finite element and object-based modeling. It has compatibility with CAD, Revit. Earlier, ETAB was like only analysis and design program, and you have to extract their ETAB was like only analysis and design program, and you have to extract Revit plugin is there. You can directly create your BIM model from your ETAB, from your Revit model. The new language, which is digital, you will be absolute. But this will not omit the engineering, basic engineering. Engineers will be there, but those who have like a dual skills, like a digital as well as basic, there is a future for them. It's a niche market. So I highly recommend people like you should learn Python, CC, Excel, Macro, VBA, all these things. Work, speed up your analysis, speed up your design, take the design data, put in Revit, like those. So these are like capabilities of ETABs. ETAB can do linear static analysis, your normal limit state or serviceability, linear 93, as well as the tall building code. and they have given those combinations also in that code, and forces to the structure. In simple word, it's not that simple, it's very complicated, but it's outside of scope. Then ETAB can do static non-linear, which we call as a push or analysis. Many young engineers come to me, I want to learn push or. So I will just give 2 3 commands. They say, oh, this is only push or, because there are only 5 or 6 commands in your ETAB for push or analysis. But interpretation of those results, it's like a 2 years or 3 years job. So I'm again repeating, ETAB is just a pet. It's not your master. You are the master. Okay. So you have to learn basic as well as you should know what the final result look like. So ETAB has capacity for multiple response spectrum analysis. I think Patil sir has done that PhD in this particular chapter. Then you can do multiple time history analysis, construction sequence analysis, which is nowadays very common for high rise, and this is a mandatory requirement for tall buildings. If we are more than 150 meter tall, and if your mass is different, construction sequence is also important. Okay, so these are like analysis capabilities of ETABS. How ETABS looks like, it is not a different animal or like. So ETAB is like it has similar. Sorry for our apologies for the image quality, because if you see the extent of ETAB is too big, and capturing all and putting all the small images will not be useful. So this is how ETABS looks like. It's similar to your STAD or your Excel. It has that top address bar where you access your commands. Then this is your model explorer. What you write in your ETAB is visible here, or what you want to model in your ETAB is there. There are these it's called as a model explorer. So there are like a model, table, reports, repo, and display those commands, and you can control your model from that. This is a 3D view. Now you should know what you are drawing or what you are writing. So it's a very visible, and the same you can work on plan as well as in 3D. You can always have 3 4 windows open. Like if you're working on plan, always open 3D view, how it is looking in 3D real life. Then you can work on elevations, how it is looking like. So ETAB has that command, like you can split your windows in 2 3 or 4 5 different windows, and you can put different viewport there, because unless and until you see what's going on, you can't work on it. The earlier engineers were their visualization power was very awesome. I saw some people like I will take name of Mr. Berry. I am a fan of him. So just writing in plan, he will understand. Okay, it will look like this. There is a headroom issue. I work with a contractor who was like roaming around compound wall and saying that column at 6th level is out of plumb. So that much accuracy was there. But nowadays there are very few people has that skill. So here ETAB has like you can work on 2 3 windows, real window, and you can work on. Then you can generate reports for your client, your peer review, because in many projects there is a peer reviewer. Whatever you do, you have to submit, just like your exam. You have to create or something, and you have to submit to the peer reviewer for his review. He will review. He will come back to you. Okay, these are the errors, or these are the possible suggestions to improve your structural efficiency. You can also work with tables in ETABS. So this is like a general overview of ETABS. Very simple, very organized, very logically put together. If you follow the right logic, you'll find your destination. That's how simple ETAB is. So this is I was talking about your user interface, where everything is controlled from this small the model explorer. Model, you will see all like details of like how many floors are there, what's the properties. Display, you can see 3D views, plans, elevation. If you want to work only one particular story, you can unhide all the other stories. You can put limits on horizontal, vertical. You can put limits on visibility also. You can see tables. Just open that cursor. 1 minute. So this is tables. You can see data in Excel format or .mdb access file format, and then report like whatever you write in the ETAB or whatever is coming into ETAB like analysis and design, it will be documented here. Like if I say for a 130 building, you will document like 1,500 pages roughly, 50 by 60 meter plan, 130 meter. It will print 1,500 pages, like 6 by 5, quite heavy. So this is how analytical view looks like. You can see all the slabs, beams, columns, elevations, foundation, curvatures, openings. See, whatever there are openings in MEP, you have to model those openings. Okay, because those opening has impact on your. Can I ask this question? If I have not modeled any openings in your slab or floor, what is impact on structure? Huh, gravity load is added extra. That's one common answer. But what other parameters will affect on the performance of the building if I have not modeled openings in my building as per MEP? Any ideas? Hello, am I audible? Hello.
Yes, sir. Your voice is clear.
Okay. Okay. So people like no worries. I will answer it. So if I not model openings in the structure, it will affect my diaphragm. Diaphragm is like is a terminology used for slab will take care of your all lateral loads and it will transfer to the LLRS or your columns or shear walls or your brace structure. And if there is a large opening to the lateral path, okay. And if I have not modeled this open, there is a column. But if there is opening, it will not water. If you put water on floor and there is an obstruction, it will not pass through it. It has to find a way through around it. So it will affect my seismic performance. ETAB now some engineers are very lazy, so ETAB comes with a direct template. You can just put direct template, just steel deck, number of stories, number of span, number of grid. It will directly give a direct a structure, ready to put for loading. If I want to go for flat slab, it will just create flat slab template. It has that much capabilities. Waffle slab, someone was asking about waffle slab. Stagger truss, flat slab, two-way ribbed slab. Everything will be like very easy. Within 5 minutes, you can create any number of floor or any size through ETAB template. Now other softwares also picking up this command, and now STAT is also coming with template. Robot, Strand, they're also coming with templates. So you will have options to do steel deck, flat slab, anything. But they have also basic commands, so like grid only. You can create your own model, start from scratch. But it will take some time. Then how your analytical view looks like and physical. There are two terminologies. One is like actual modeling, and I'm just 1 minute. I must have. Yes, I will just jump to this slide first. So this is a like realistic modeling. So if can you imagine like this is actual construction. There is offset here. There is a column here. There is no column here. There is a next column. Then again there is offset. There is a two-story, and there is a roof here. And you have to model similar way. See, there is no column here. The column is stopping here. There is offset here. There is again offset here. So you have to match all realistic. You want to build that site, you should model at the analytical model. Any irrespective of any software, you have to model it. Behavior of the structure. Correct. I'll just go back to the slide here. Then analytical view and physical view. Physical view is like a extruded view. You can see, okay, how the beam is looking like, how the slab is looking like, where it's sitting. And analytical view, all softwares are work with a center line method. When you assign a column, you have to put at center. When there is a wall, you have to draw from two lines. An analytical model is like a free body diagram. It's like sometimes the teacher gives us a simple job like, okay, draw me free body diagram and the load path. So this is like analytical view. It's like a free body diagram. Then physical view is there. ETAB has capability of like all type of grids. It can do a circular grid, square grids. You can define as per own DXF also. You can import rather than creating your grid system manually. You have to draw something in your CAD in DXF format, data exchange format, central model, and you can import that file directly in ETABS at any level. Sometimes you have podium level, basement level, typical level. Typical level also there are two, three options: small plate, long plate, different column configurations. You can import all these DXF files into ETAB rather than creating grid system. So first we will go through the basic commands, and then how the importability or digital will help you. I will teach you. Then so this is normal grid system, and you can add any floors any given point of time. Like if I design building for G+2, and later they want to do an expansion for ground plus another one story like G+3, you can just add, copy, and just put it back. There is no manual work, very automatic. You can copy whole floor and replicate at upper floor if you want to work on that way. So editing is like a very simple. It's like using your Facebook. Very simple editing grid. So these are the 3D views. You can see 3D views as I mentioned in the first page. You can see 3D views, plans, elevations or sections. This is the wall with number of openings, because in shear wall system, my one is a good example of shear wall system, but it comes with a all shear wall system, my one, because they want to save in construction cost and time. So they have ready-made formwork for like a massive township of like 120 apartments or 120 bungalows. They will start with like tap 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 with the doors, windows, everything RCC. There is no brickwork. So in this scenario, you have to model in that fashion, walls with openings, and ETAB has that capability to work on the wall with openings. You can see object by actual assignment. You can put your random colors also. If you want to give color to column as a pink, the columns will be pink. It's up to you how uh, you compatible with the colors, and it's very visualized. You can see half floor, full floor, half window, full window. And this is what I explained, your realistic modeling. Your model should be realistic, but again, it should not be only picture. There should be engineering judgment to it. Like I will give you an example. If there is a long column like a 2.6 meter, and ETAB, I will just draw one minute. File new PDF. Yeah, can you see the blue beam window? Hello.
Yes,
Yes,
sir,
sir.
we can see it.
Okay, thank you. So this is my column, and this is my beam. red one, this is a column. Real life, but ETAB will consider the beam, the column is not supported along the horizontal direction because the beam is here. It is not in real life. The column is well supported in horizontal direction. Are you agree or not? Hello?
Yes.
It is
Yes,
well
sir.
supported, right? But due to ETABS, how it works with the line element, it will not consider the column is supported along horizontal direction. And if the openings are for 2-3 floors, it will consider the slender for the effective length of column for those 3-4 floors. It will add, if my typical floor height is 3 meter, so for 4 floor it will consider 12 meter effective length. But in reality it's 3 meter, right? Because every floor there is a beam at edge. And here your judgment comes. You have to go and check how the effective length calculations ETAB is doing. Is it considering as per its free the line element thing, or as per real? If it's not considering as per real, then you have to change that. Otherwise, this column will fail. And it's a real happen in my one of my project. My engineer was telling me that this column was failing. I was like, how it's possible that column is not carrying any load? There is an opening around both sides, and there is a very the span is very low there, 3 meter only. How it will fail? It's a massive column. Then I understood, okay, because of that slenderness check, that column was failing. So this is where your logic comes, engineering judgment and logic. Okay, so you have to take care of that also in your realistic model. You have to connect some dummy beams there. You have to assign some kind of support or slab there for your beams or columns to get real modeling. Again, ETAB has an interactive database, like you can see the model explorer. You can highlight one level and this is visible. You can run with 3D view, plan, and at the same time it is giving access to your database like joint coordinates. And by giving your API access, you can play with geometry through your Excel sheet. It's not like you have to go and do something in ETABS. Through your Excel, you can create a ETAB model, but you need that coding expertise. Then the main thing here, like ETAB also is object-based modeling. So ETAB has like a 3 basic classifications: area objects, line objects, point objects. So area objects, as a name, it's a planar element. So whatever falls in area is wall elements, slab elements, and openings. ETABs assign or classify them as area objects. So shear walls, floor slab. There is a deck slab, flat slab, waffle slab, ribbed slab. Uh, any possible, like two-way, one-way also is possible in ETAB. So those slabs can be modeled in ETABs. Openings, there are floor openings, there are wall openings. You can model. Beam opening is not possible. Again, beam is not an area object; it's a line object. So these are area objects. Okay. Then there's a line object. In line object, which are like a 1D elements. And which are the 1D elements? Like columns, beam, braces, links. Columns, vertical elements, beams, horizontal elements, brace, inclined elements, links. Now you must have done your ME thesis or bachelor's thesis in like uh, isolation systems, damper systems, link elements. Those are link elements which are joining two elements. ETAB has that capability through line objects. In point objects, every object, area or line, it has a one point object. This is by default. Okay, when you draw a line, it will create a line in two joints for you. Instead, it was you have to create first node, then connect these two nodes. This is not the case with ETABS. You can just draw a line, it will create uh, nodes for you. Then you can assign springs to that, supports to that line object, point object. This is very, very easy thing. And this is the basis. You have to understand the real meaning of your actual, what you call as a column, and it's a line element. Okay. And the assignment of like a section assignment, frame assign, section assignment, load assignment will follow the same order. If you want to assign a floor, you have to go into area object. If you want to assign a load to area object, you have to go area loads. If you want to create a column, you have to go to the draw line, then column, then beam. Okay, very, very simple. As I mentioned earlier, if you have a simple logic, you will find a way in ETABS. It's not a big tool, but you need a engineering way and holistic approach. Moving to the next slide, you can define n number of sections. There is no such limit in ETABS to drawing or defining any section. You can, I'll just highlight. You can draw concrete, you can draw steel, you can do spatial, you can decompose it. Concrete, what you are seeing at your home, it's a normal concrete structure. You can draw square, rectangular, circular, T sections, girder sections. In steel, you have catalog, you have access to European, American, Chinese, New Zealand, Indian, all possible manufacturers catalog ready. However, you can also define your own built-up sections. Nowadays, there's a new trend of built-up sections because people think those are very, very cost efficient. But at the same time, they are forgetting about their quality because built-up sections are manufactured through plates. And like, I don't wonder if people say they don't aware about WPS, WPQR. WPS is like welding procedure specifications. And WPQR means welding procedure quality records. So if that manufacturer has that capability to build as per specifications 6 mm fillet, it should be 6 mm only. There should not be any intrusion, extrusions, or shortage of run. So quality is a big thing for built-up sections. But there are few good contractors also like Eversundai, JSW, Tata. They have good testing house, so they can help you with the build-up section. But I have very big concern on the conventional fabricators. Then you have special, you can do two things together like L shape, C shape, concrete. Any irregular shape you can do in section designer. You can define your section by perimeter also. If your architect is very artistic and he say like he want to construct like a odd shape with a profile concrete column, how will you do? It is possible. You can do a section designer, you can define a column by perimeter. It's possible. Steel composite, this is, I said, it's coming very fast to our industry. For commercial buildings, there are very few buildings which are in composite at the moment because of cost, but construction cycle is like half. You can do uh, CFT means concrete filled tubes. This is very fast. Formwork is very, very good. There is no requirement of formwork because the tube itself acts as a former, and you have to put rebar and concrete inside. The steel, then composite eye like concrete with encased. Means there is a concrete outside and there is a steel inside, and then again CFT, 2-3 sections. This is how it looks. How to define? You have to give parameters like what's the top flange, bottom flange, thickness of flange. Then it will create. You have to modify also. This is how RC elements look like. This is steel one. This is concrete one. And as I mentioned, section designer. By section designer, you can draw and define anything. There's a limit to your imagination, but there's no limit in ETABS. For section definition, for others, yes. So you can use a section designer. You can model any size, shape, angle, elements. And as I mentioned, like we'll go with now each element, shear walls. So for, if you see, for multi-story buildings, they use shear wall system for your lateral load resisting system, and your slab as a deck slab or waffle slab, anything, and composite structure also at some point. And you can define a core in, if you see the previous example I saw, share, it's a core, proper core with a like outer core, then inner lift walls, staircase wells. So you can define your core system here rather than creating and joining all these shear walls manually. You can define your whole core length. There's a standard definition also, you can draw also, or you can import also. So this is new feature ETAB added. ETAB started with ETAB 6 and 9, but now 2018 is very refined version, and they have just ease your life and your experience with ETABs. So you can actually model whole core in one go rather than creating a number of shear walls, 1, 2, 3. You can define one go. It will assign peer labels. We'll come to know, come to it later or tomorrow. Then the links elements. I'm just again touching very important or unique ways. So this is link elements. You can model gap elements, hook, isolators. So there are two: rubber isolator and friction isolator. You can work on those. You can give these properties to links. This is for your pusher analysis. You can give links to the. So these are like a definition. What's the stiffness in vertical, horizontal? You should have those data. ETAB by default don't have any data. It has only provisions K1, K2, K3. So these things you will come from your manufacturer, your technical papers. This is what I'm going to talk about, floor diaphragm. So shear wall is your lateral, but who is going to transfer your floor load to the diaphragm? Floor load or lateral load to the shear wall. Lateral load, it will first strike to your slab, and slab will act as a medium only. It will not resist your lateral force. It will simply go to the your LLRS. There is a two terminology here. Shell element, you might have learned in your technical. Plate, shell, membrane. Plate is your outer plane. Shell is no, then membrane. Membrane is in plane, and shell is combination of in plane out plane. So if your floor is modeled as a membrane, transfer directly 100% load to your LLRS. It will transfer. It will resist some part of it itself only, because shell has capability of resisting in plane as well as out plane movement. Okay, so you have to take and you have to modify those property modifiers. F1 means along axial directions and bending directions. Then coming to seismic loads, I'm just briefly touching on all these subjects. You will see because tomorrow we are going to learn basic commands and like a proper structure. And if you have that ETAB setup ready with you, that will be very useful. You can directly experience live modeling also. So as we discussed earlier, like we have to give direction, then the, the story range from where to where you apply seismic load. Can anyone tell why there is a range given for foundation? Like by default, it should be foundation only, right? But why they give this bottom story? Any answer? Because
So for
seismic force,
base shear,
base shear. But why they given a flexibility to user to define your bottom story? Because the seismic force generated at base, right? Because acceleration comes there, and then it will get transported to your structure. Then it should come to the base only. Why they are giving you flexibility for bottom story?
in the IS code, there is a formula for time period, and because of that,
Yes, time period, there is a formula you can consider from ground floor, from base. But why this is given? Why code is also giving that formula? So if my building is a residential or commercial building, if it has podiums and basements and retaining wall, okay, so the retaining wall, you if you have basement, four basements, then you construct a perimeter retaining wall which is strong. Okay, then there's the ground floor, and then the building starts. That retaining wall itself act as a box system. It's very rigid because the retaining wall, it's a massive 400 thick of throughout the perimeter, and there is an opportunity for you to define your seismic grade. Seismic grade is a level where you want to transfer your force. So all the building force will come to that level and it will dissipate it through floor diaphragm to retaining wall, and it will go to the foundation. I will recommend the read of IS 1670 backstay effect. It is for retaining wall, building with retaining wall and building with multiple towers with common podium. Backstay effect. Just read it, you will understand. Then there's a definition for response reduction factor. You have to give PGA. You can user define also if you have, as I mentioned, if you have a literature on probability seismic hazard assessment, PSHA, you can define your own PGA. Then site important factor 1, 2, 5, whatever you want. Then by default time period. This is done. Seismic load is done. Within 45 seconds, you can define seismic load. But what to define at what location, it's your responsibility. Here your engineering judgment comes into picture. Definition in ETABS very simple. This is the only one table you can define your seismic load. Very easy. But what's the basis of bottom story? What's the basis of response reduction? What's the basis of this zone factor? What's the basis of type? How, just tell me, if my soil is 1, it's a hard rock. If my soil is 3, which is very soft soil, what it has impact on my seismic force? For rocks, it's a very strong, dense material, right? So it will not transfer all forces to the structure. It will dissipate some amount. So seismic force in a rock is quite low. In soft soil, it is very high. Okay. Then time period is based on fundamental time period. This table is for your equivalent static method. Equivalent static. Similarly, wind load, again, very small table. Just give K1, K2, K1 and K3. K2 it will directly calculate for you. Then give CP, windward, leeward, exposure, shell elements, wind speed. That's it. It will calculate wind load for you. Again, why not base? Again, they have given definition here. This is for if your building has podiums and basement. For below ground structure, there is a wind load, right? So you can say here ground floor, and basement 1, 2, 3, 4 will not participate for wind load. Okay, that's why they have considered. They have also given parapet because ETAB model only floor. They don't consider that parapet. So for wind calculation, it's an exposed surface, right? And it will add some extra load. So they have given this parapet definition. If you say here 1 feet or 2 feet or 3 feet, generally it's a 1.2 meter. It will add and it will calculate load for you. Don't have to do any manual calculations. So sometimes you have to give some joint loads. There is a crane, or sometimes there is a gantry. You have to define your joint loads. Then you can define these joint loads. If you have not assigned your diaphragm as a rigid, then the seismic force will apply on each floor, because I told you diaphragm is definition to apply a seismic force at one center of mass or center of stiffness, and then it will, as per the length and stiffness of that element, it will get transferred to that element. If you're not assigned floor diaphragm properly, it will apply as joint load at all joints. Okay, this is line. Line load, tell me the examples of line load, like when you want to apply a line load. So there is a wall load, there is a facade load, there is a curtain load. If there is an auditorium, that curtain window that the bell person rings and that opens, that the weight of that cloth is also heavy. Sometimes it goes to 5 kilograms per meter, more than that. So that kind of loads you have to apply. Then again, as you discussed earlier, there's a live load reduction factors. As per, there are different methods in US. There is a tributary area method, average area method, shell area method. But in Indian code, it is a story defined. This is story defined as per, and you can apply for only for axial or all components. Okay. Now coming with the dynamic analysis. So dynamic analysis means what? Finding out the fundamental frequency of the structure by, there are two methods. One is eigen method and there is a Ritz vector method. Both are different. Eigen works with your stiffness and everything, but there are Ritz work with your loads and everything, applied loads and everything. As per CSI, both are good, but as an industry practice, people follow a Ritz vector for your dynamic analysis to find out the mode shape. How building, if you see, this is the your building's first mode, how the building is behaving in first mode, second mode, third mode. And as I mentioned earlier, the first mode should not be torsional mode. The first mode should be torsional mode. Second should be translation. First mode should be translation. Second also translation. Third mode is fine if it is a torsional. Okay. There are some clause in IS 1893 also. I will recommend to go to table 6.1 to review the rules for modal participations. You must have learned your masters that it's a response spectrum is like a finding the mode shapes and modal mass. How much percentage of seismic weight is participating in that mode? That is a modal mass. So code says in first principal direction 3 modes, the mode mass should be 65% of the total mass. Then they say the difference between first and second mode
Yeah, let me check with that. Wait.
I think I lost the connection. Hello? Hello?
Real MR.
Yes.
Yes, sir.
Hello?
Yes, yes.
Same thing.
I
Yes,
think I
sir.
lost the connection.
You- Yeah, yeah, yeah. No issues, sir. You can again start your presentation.
Okay. Okay. So I think we were discussing about dynamic analysis, right?
Yeah.
Yeah. So there are two methods. I don't know when I lost, but I will just repeat last 1 minute. So there are two methods: eigenvector, eigen and Reed's vector. So CSI is claiming both are good, but industry is saying Reed's vector is more good for analysis, and as well as it helps for your P delta analysis, because P delta analysis is now common for all the structures. So as did I mention about code also, IS 1893, or I will again repeat. So as per IS 1893, there are some rules for your dynamic analysis. First, the first three principal direction mode participation should be more than 65%. The first two modes shall be different in 10%. The total mode mass should be 90%. So I highly recommend students to go and read the IS 1893 for specific requirements from the code. Okay. So I will just briefly discuss about other parameters. 1 minute. I will just jump to other. So response spectrum analysis. So response spectrum analysis, again, I will go to the basic. A response spectrum means what? There are different time histories put together and a common curve is plotted. So this particular is a plateau and it start reducing. So as your building is flexible, you will experience a less SA by G. So there is a two common terminologies. One is a flexible structures, one is rigid structures. Flexible structures means high time period. If you see, for now for code is saying, like earlier our buildings are stone buildings, very ground plus one or ground story with a massive mass. Those are like a rigid structures, and those are also good for seismic resistance, but mass is too high. But nowadays we can't build something rigid structure, which will be very costly affair. So people started with the flexible structures, and the super flexible structures are like buildings on isolator. There's only one building in India which is an isolator, which is Bhuj Hospital in Gujarat. They have built after 2002 Bhuj earthquake. But in Japan, like, and out of 10, 3 buildings are in isolator: rubber isolator, friction isolator. They have some there in patented isolators also. Okay, so this is basic common terminology for a rigid and flexible structure. So yes, you can define response spectrum directly from IS 1893, ASC 7, British codes also. The ETAB has capability to take help of or define any spectrum defined by code automatically. Or else you can define your own spectrum. For dams or for bridges, they perform a site-specific response spectrum analysis, SSRA, site-specific. They don't follow the codes. As per geology of the structure, the fault line you must have learned in geology. I learned in third year something. Geology, fault line, the duct or the dike, then properties of the soil, and it has impact on your soil classification and seismic performance. You can do a site specific and you can define your site specific. So by default is possible, user define is possible. Okay. Then time history analysis. Those are dynamic analysis. For time history, you have to define a time history. By default, you have access to all like a 30 or 40 default time history analysis, like El Centro, Hostile, Parate, Loma Parate, all are possible. Otherwise, you can define or import a text file in a standard format and you can define your own time history. So these are actual time histories. You can also put a sine time history, cosine time history, ramp time history as per the basic time history analysis. That's possible. And you can define one after one, like after El Centro, Loma Parate, North Ridge, Kobe. You can define multiple time history analysis. By manual calculation, it's not possible. So again, I'm repeating, only advanced analysis and everything you can do with this technique. But basic, you should be have full hand on it. Then I will just go to 1 minute. So dynamic overview, see response spectrum, time history, linear integration, then P delta. P delta is like a secondary structure, secondary movements. You can define, you have to just define P delta combination in your ETABS. It will take care of it. There are two, compression and tension, but as per forces, it will take care of it. Then actual buckling, you can see in ETABS. Actual buckling, how it is deforming. Okay. Then I go to one low very simple name. So earthquake loads, wind loads, you can define as per code automatically. You need not to do any calculations. You have to define only parameters like uh, PGA or wind speed or K1, K2 factors, and it will calculate for you. Again, ETAB has a direct load combination method also. If you select your code, if you see here, steel design, it will directly give a load combination list for you as per IS 456, as per IS 1893, or international code like AC7. It will give I have to do like a 10 scenarios. Like if there is a load, I load on cantilever, and if there is no load on the back tie, what will affect? What will be impact? So those kind of combinations I have to prepare. The load applications also. So user define is also possible in ETAB. Auto lateral loads are auto load combinations are helpful to save your time, and also you can define your own combinations. I'll just go to this is construction sequence I just discussed in the first slide. What do you mean by construction sequence analysis? In a large structure like a 100-story building, the column which is the first story, if you build another floor, it will settle a bit. Okay, it has designed for 100-story, but for its self-weight or 100-story dead load, it will settle something. Those effects you have to consider. And for that, construction sequence modeling is very important. Okay. Then, as you mentioned, you can define load combinations. There's a new method is coming. Is performance-based design. Like there's a limit state method, serviceability and strength. There's a performance-based design method. Here, the client or the main engineer has capacity to define the performance. Okay, if my building is moving by 100 mm, I am fine with it. If my building is moving by 200 mm, I am fine with it. And as per that, you have to assign hinges to your structure. It's like push-over analysis. There are two methods, like a fiber hinge and elastic hinges. At the moment, they are doing only elastic hinges. So For columns, they assign PMM, axial and movement, both as well at both ends. For beams, only M3 because beam is governed by movement and shear, so movement hinge only. For braces, it's an axial hinge, and those parameters will be given by a separate software because ETAB also has feature to define by default hinge. If you just define some rebar, it will give you by default, but this is not the true because in real life you are going to define rebars, concrete grade differently, link spacing differently. So there are few softwares like Sysmostruct, AdSec, Extract. These software will help you to define actual movement curvature, and those values you can import into ETABS to define user specific hinge in your model. Default is possible as per FEMA ATC, it will give you default hinge, but it is always good practice to define your own hinge based on actual properties. That's the best way. But for quick calculations, you can use by default hinges as per FEMA and as per ATC. Okay. So these are like hinge patterns you have to define. Then this is like a fiber hinge modeling, auto fiber hinge. These are like advanced techniques in ETABS. But you should have proper knowledge of the real basic behavior of the hinges. There is a book by Princia. You have to read in depth to understand the definition of hinge and definition of performance based design. Because in ETAB, there are only 5 commands. Only 5. Select a beam or a column, assign hinge. That's it. And there is one window which will define some other parameters like it's a force control or displacement control. In displacement control, what's the displacement you want to put the building. So it's a like 5-6 commands steps, but understanding of the hinge patterns, there are like 5 life safety, like life safety, evaded occupancy, critical prevention, collapse prevention, or collapse. And as per that, you have to understand that color of that hinge, yellow, yellow. Nahi. First is that gray, then yellow, blue, then red. Red is a collapse. You have to understand that theory, and then you have to apply use ETABS to help you with the proper results. Okay, so don't say like learning by 2-3 commands in ETABS you will learn performance based design. No, that's not right. You have to read the theory first. Then in design you can design steel frame as a design, like interaction ratios for beams, columns, braces. Steel design is possible. You can see the codes. I will just explain you. One minute. So these are like possible codes which can be supported by ETABS for your steel design. Our IS 800 is here, 2007. There are some Korean codes. Special publication is also there. It's very new thing. Then AIC 360, 10, now it's 16 is there. And these are the ETABS feature. That's possible. Concrete frame, again, it supports all possible codes, ACI, BS, Eurocode, Chinese, and our IS 456. Some Korean codes, New Zealand code, it can support all possible codes. Composite beam design and slab design, see, there is a Eurocode 4 AIC 360, but there is no Indian code. There is one Indian code 115190, but that is too old. It doesn't give any reference or guidance on the composite design. So much popular is your AIC 36016. It's American code. These are earlier versions. And there is a Eurocode 4. This is Eurocode 4. It's a British. There is a Chinese. There is a Hong Kong code also, but not supported by ETABS now. See, there is no, for composite, you have to refer to other codes. Hmm? Masonry wall is possible in ETAB by ACA 350. If someone is doing your uh, infill wall analysis, like buildings with infill walls, you can use this ACI 530 code. Slab is also possible in latest ETABs. Earlier it was not supported. Earlier it was done in safe only, but you can refer all these codes. We have IS456 also, Singapore code. This is like a Chinese code, tall building code they have. Cold form frame design is also possible. Cold form means there is a two method, like hot rolled and cold form. Cold means you have to bend directly. So like a GI sheets, there is a Tata Structura. They have good webinar on this cold. You can design that. You can design steel joist design as per SGI code Singapore. Then there is again some American codes are there for aluminum frame design. Bridge they have Indian. There is Indian code also IRC 2011. So see, the ETAB supports all possible international codes. You can see output and display in Excel format. You can change your units any given point of time. You can check shell reactions and everything in a very organized manner in tabular output. You can access through Excel or text. You can do section design. You can see render views. ETAB has that capability. You can record your time history analysis through video AVI file. You can see rendered views because your clients are non-technical. They are not interested in your beam column story. They want some visualization, and to just make them happy, you can give a rendered views. And I will give you one more software name. If you have time, you can note it down. Rhino. Rhino and Grasshopper are best tools available for rendering. You can export your ETAB file to Rhino, and you can do wonders in Rhino. You can actually control your ETABs through your Grasshopper. Grasshopper, again, it's a scripting tool. It's like a visual scripting. So if you have time, you can learn in this COVID pandemic time. You can learn. There is a good webinars available. So Grasshopper, Dynamo, Rhino are these drafting tools actually, but you can work with that your ETABs. I will give in displacement, and for that you have to discuss with the actual vendors who are into this field, and you have to take that data from them. You have to define your problem to those vendors, like this is a displacement, this is a structural properties, time period, displacement, and stiffness, and they will provide you specific details, those spring mass values, and you have to define that system in your model.
Okay. Okay. I think you were not audible to him at that time, so he requested once again to discuss this particular
Okay,
point.
okay, okay, no problem.
Okay, I think one more point is there. On what criteria gravity columns are defined apart from remaining moment resisting columns out of the total columns in the system?
Okay, so the columns who are part of LRS, that is lateral load racing system, those only load combinations like earthquake, wind, and gravity. But those who are not part of LRS, which are simply supported, there is a command in ETABS, you can put releases to beams, and columns is not recommended. Put beams releases, so they will not participate in your lateral load racing, and those columns shall be designed only for gravity loads. But in IS 16700 code suggests to carry out a deformation compatibility check on for those columns. It's only ductile detailing requirement. If you see your the perimeter columns, which are generally part of LLRS, if they are moving by at certain speed with certain displacement, and your gravity column, which is not designed for that particular extra lateral load, it will deflect, but it will crack because it is not designed for that, for ductility. So you have to run R is equal to 1 model, because your by default model will be R is equal to 4 or 3 or 5 also. Then you have to again rerun this combination with R is equal to 1, and you have to design those columns which are gravity column for inelastic forces. Again, only for gravity. You have to design those for lateral movements induced by lateral displacement of the seismic. The you have to refer guidance, because IS 1893 and 13920 and 1670 are not properly defining this specific clause. Right, Mr. Sri Patil? Does this answer your question?
Yes, sir. Thank you. Yeah.
Thank you.
I got it. Thank you, sir.
Okay, I think that's it from question answer session. To thank Mr. Sudhir for very nice presentation. Participants really liked the way you presented
Yeah,
it. You have given the information in actual field also what scenario we are facing. Right.
yes.
So thank you. Thanks a lot. And we'll continue tomorrow with same speaker. I think tomorrow we'll have direct modeling using ETABS.
Yes.
Right? So that's it from today. And tomorrow morning before 10 a.m., I'll share the link with you all. Till then, goodbye from my side.
Yeah. Thank you, everyone. Thanks. Nice audience. Bye bye. See you tomorrow.
Okay, sir. Hello, ma'am. Hello.